we will run the simulation for the blowout control for the Rayyan well. You can see the plots will moves here the influx from the reservoir volume rate per minutes, time and rates, and we can see here that the influx from the reservoir gas fluid to the well, to the gas blowout well, and accumulation. For example, the influx from the reservoir by volume rate, it is 200,000 cubic feet per minute, and for the 6 minutes, for 1 is 0, for 2 it is 5 or 30,000 cubic feet per minute, and it's increased to 200,000 cubic feet per minute. In the Aleph reservoir, it is the formation name, and accumulated gas volume out from the annulus and the mine well. It is 100,000 cubic feet, tank feet, barrel. And the free gas, as we see here, the volume, we have the annulus, it is the blue, and relief drill string, it is yellow, and relief annulus, it is pink, and relief kill line, it is green. Kill line, relief kill line for the relief well, relief drill string for the relief well, and relief annulus, it is the pink, and the blue, it is the annulus for the mine well. We have relief drill string and relief annulus, which blowing out the gas from it, and annulus for the mine well. As we see here, the annulus for the mine well, it is 100% volume fraction percentage, but for the relief annulus, it is started from 0, and relief kill line from 0 to 20 by the depth, and pressure at casing show. Our pressure at casing show at the reservoir, it was 2000 psi at the depth or at the reservoir, and it is increasing to the 3000 and more after 2.5 minutes, and decreasing to 0 or to 2000 after 8 and more minutes. Pump pressure, we have the relief drill string, the blue relief drill string, it is for the drill string for the relief well, and the relief kill line, it has the constant, but start from the 30 psi pressure and constant about the 18 psi. But the relief drill string, it is started from the 60 psi and decrease to the 10 or 12 psi after half or 1 minute, and it is constant also. We can see another custom plots. We can click here and add new page, or can load the page layout, add, and the custom plots we can add as we see here in our kill screen, pressure, equivalent circulating density report, as you like. We will go to the default plots, influx, and our, as we see here, if you have this the accumulated gas volume, it is increasing per time, and the influx also increasing and decrease to be constant. And the other kill screen free gas influx, it is the same. Not, for example, we have the bump volume rate or bump pressure. You can add here set by the right click, and trend accumulated oil volume out or gas volume out, accumulated gas volume out. It is the accumulated gas volume out from the reservoir. After 10 minutes it is 250,000 cubic tank barrel or cubic tank for the gas volume out. If we can change, we can remove or reset, bloat or remove or add. If I click in the right place, I can add right trend, and or we have the 3D well bore for the gas fraction gas volume. For example, free gas, how many have for the free gas? Oh no, set 3D free gas, it is not working. Maybe set 3D fraction pressure losses gradient. Why 3D don't working? And we can see here the influx gas from the reservoir. We can follow the simulation and add the right 3D, for example, pressure inside the well. Why not? Gas density, yes, we can see the gas density in the 3D plots. The gas density, it is less than at the top, and in the bottom of the well it is high gas density in annulus. We can set or change the 3D, for example, effective oil viscosity, fraction pressure losses at annulus. We have the losses at annulus more than at the bottom in the reservoir, and it is decreased to the head or wellhead. I can shock pressure, blowout pressure drop. I can see here the mine well, it is the blue, and the relief well, it is blowout pressure drop. At the relief well it is 0 psi, didn't have the pressure, but at the mine well it is more than blowout preventer pressure drop 0.2, and this is increased and decreased to other. We can change here set. When we select set, we can change this plot to another 3D oil profile. Gas velocity, for example, we can see gas velocity at the well, at annulus in the mine well, it is increasing by the depth to 700 and decreased to 470. Relief dressing, inside the relief dressing it is orange, and the relief annulus it is pink. You can see here pink or not, and it it is the relief drill string. Inside the relief drill string, it is 0 velocity by second, and relief kill line, we can see the green relief kill line. Also we can add set inside this any plots you like to see: water density, total mass rate, liquid mass rate, liquid velocity, mixture density for the fluid. It is the mixture at annulus for the mine well, and relief drill string, it is the orange. At the relief drill string, it have more than the density 35 specific gravity, and relief annulus, at the relief annulus it is 14 specific gravity or pound per gallon, and relief kill line it is 14 also. I can add here, I can rename here if I want rename, and mixture density or blowout pressure drop. I can write anything: blowout preventer in English, blowout preventers, pressure drop. I can add new page and set any of the plots you accumulative value volume, influx from reservoir, mass rate, influx gas oil, total influx, this is the total influx, mass, pound per minute. In the current we have the total influx from 0, it is to 118,000 for the mass by the after 23 minutes by time. I can add or write here, add right, and add the 3D for this total influx. If we have measure total mass rate, we can schematic what, because we have this is the total mass rate in annulus. We have the losses here where the red total mass rate at annulus. Also we can set inside this about what outlet gas velocity, set profile, mud mass fraction. Mud at annulus we have the fraction at the depth of 8,000 feet and 8,300, for example. It is the mass fraction more than 83% in the annulus. But the relief well we have here, the relief well it is okay, and the relief annulus it is constant 100% relief annulus for the relief well, but for the relief kill line it is okay at the head 0 feet from the 0. No, it is constant after, but we have the relief annulus 100% and the relief kill line it is less than 99.9%, but at the annulus it is more than. I can set or change this by the fraction losses gradient. I have the slab. The fraction pressure losses gradient at annulus, or set another 3D well bore. Liquid density hydrostatic pressure gradient. Also it is the slab's weakness. It is the hydrostatic pressure gradient at annulus. We can see the change from the dark blue to the dark red, and again blue. It is the losses pressure also at this for the relief well. You can see the summary. We didn't have anything. Trend, accumulated water, no, blowout preventer, or everything of this. Plus you can add to your simulation and see outlet gas mass ratio, outlet gas velocity, liquid density, oil, but we have the gas. Influx gas oil ratio, if we have. We don't have gas oil ratio. The gas density, look here, the gas density at annulus for the main well, it is the density less than 10 or 9.9 pound cubic pound per cubic feet. And the relief drill sling, it is the curve orange, and relief annulus for the relief at annulus, it is the pink, and the green relief kill line we have at the wellhead kill line. So you can add what you like to add from this curves or plots: total mass rate, water fraction, gas velocity or trend, accumulated, blowout preventer, choke pressure drop, choke pressure, influx from reservoir, influx gas from reservoir, volume rate, as you like. You can add anything. Free gas, this the free gas, 3D free gas, it is all blue free gas. It is high pressure, high temperature. We know that the gas, it is high pressure, high temperature, and when we rescue the main well, which is blowing from the by gas, we inside the relief well, we can rescue this well by open the annulus for free gas to get the pressure to the another relief well, and to rescue the our main well, which is have the gas reservoir with high pressure and high temperature. Add, for example, effective circulation density. Look at here, effective circulation density by the depth. For the annulus, for the main well, it is the density start from the, for example, I can remove this 2C by 1 by 1. Oh, first. It is started from the 20 equivalence density, and it is drops to the 4 and 25 and increase and drops. It is the not constant, and it is at the bottom of the depth, it is increased to 12 pound per gallon for the density at annulus for the main well, which is blowing the gas. The relief drill string, at the relief drill string, at inside the second well, relief well, dressing, it is about, which is intersection with the main well at the 8,000 and some 200 feet. It is 10 and 3.3 the density at the relief drill string, but the relief annulus, at annulus, it is less than the relief inside the relief drill string. And relief cal line, it is the at the top of the well, and at the reservoir we can close or remove this to see. At the Alv reservoir it is 12 and some 12 and 2.2 the density at this reservoir, at Aleph reservoir, and we can see here all together. And you know, we have this one, it is the fraction pressure which we added here. Fraction pressure, it is, we can see here by the this line, black line, it is more than 16 or outside. We can add here the equivalent density set as 3D if we have the equivalent density, but it will be, see here, we have the equivalent density, we know it is this before the reservoir, and more densities for the equivalent circulation density at the reservoir. It is the high density because we have the high gas pressure in this reservoir of gas, dry gas. And we can here write, rename the custom plots to the AECD, for example, AECD. And every port or every plot you can export and save, export as GPG, BTMAP, or the XEB PDF, and select where you can to save, or you can also copy or save or send or preview as you like in the PDF, for example. Or save, you can click on save, where you save your blowout control. You can here write the blowout preventer as the name of the plots, pressure drop, or as you like. And click save, close. You can see here the blowout preventer opening at the relief well. Why we are opening the blowout preventer? To allow the blowing gas to flow inside the relief well, and this the main well opening and the relief well opening the blowout preventer inside both of wells to rescue this well from blowing out the gas. I can add here set 3D blowout preventer. We don't have here. Gas density, I don't have I want the profile or for the gas density, the density for the gas, and you can add any plots. So you now risk this blowout preventer, which we have the intersection in this point, and from the high pressure, high temperature from this reservoir, we can opening the blowout preventer for the main well and for the relief well, and to rescue this well from the blowing out or from the catastrophic. Okay, we finished the fourth lecture, and we have the last lecture number 5. It is the last section in this course of drill bench course. We will continue and discuss this lecture 5 lecture with you after 2 days, inshallah. Goodbye, good night.